All right, well, I guess we'll just go ahead and get started. First, I guess, is there any questions about anyone has before I start talking about some work that we've done with h5fuse script?
Scott, I just have a very general question in
Mhm.
terms of the subfiling VFDs. Uh, Can you describe sort of the typical users of the subfiling VFD? Like, where do they exist in the spectrum of HDF5 users in terms of magnitude of data that they're dealing with and things like that? Is there a typical user of the subfiling VFD that then goes on and is going to be using the commands like fuse?
It's basically going to be applications, scientific engineering applications that are writing pretty large HDF5 files in parallel. So any.
So can you elaborate on pretty large, just because that
Well, not
I know
even
that
necessarily,
expands a lot.
it doesn't necessarily have to be large. I mean, it could be small. It's just if they're using a large number of ranks, it's more because when you get to over 1,000 ranks, then you really start to see issues with writing to one single file. And subfiling was created to kind of address issues with large exascale type problems where you're running tens of thousands of ranks and you don't want to have all those ranks writing to a single file. That's really the use case that was subfiling is really meant for. So it's not necessarily the quantity of data that you're writing, it's how many processes are writing that data.
I see. Thank you for the clarification, because I do think that that points to a larger issue. There are so many dimensions to what you might call big data, right? Because here it's not data sizes or complexity of the hierarchy or the model, as you have told me here. It's just has to do with the ranks in terms of the parallel processing. So it's yet another characterization of what it means to have big data. And that really spans everything. In other words, big data means all sorts of different things. And here it really, as you have described, it means the number of ranks that you're using. So it points to sort of what I think is a bit larger of a problem in, define big in big data that HDF5 is used for. So I appreciate the perspective. That's I just thought maybe I'd ask that before you kicked off on the nuts and bolts here.
Yeah,
Okay, thanks, Scott.
good question. Okay, anything else? Any questions before I start? And also have questions afterwards if you want. Okay, so let me full size my screen here. Whoops. Which slide? You probably see this slide. Let's see here. Okay. So in case you don't know, h5fuse is a script. When normally you have subfiles, when you're using subfile in VFD, it creates a number of subfiles. And if you want to then have a valid HDF5 file, you have to fuse those files back in. Now, that's not to say that if you want to read those subfiles back in, that you have to fuse them back into an HDF5 file to do that. You don't have to do that. You can just, as long as you're using the subfiling VFD to read in the subfiles, it should handle it fine. So in order to read the subfiles, you don't have to fuse them back in. You can still use the VFD driver to read the subfiles. This isn't the case, for example, the application I have, which uses the XDFM file format. I mean, that points to an HDF that needs an HDF5 valid HDF5 file to be able to read it. So in that case, if they want to visualize the data, you have to have a valid HDF5 file that you're pointing to. So in that case, which is the application I'll highlight, you need to put the files back together. And to do that, you use the h5fuse script. And basically, you can look at it here. It has when you build a library, it's going to build the h5fuse script and put it for CMake, it puts it in the bin directory that you install it. We just add the capability that if you use Auto Tools, it also will do that. But currently, if you're using Auto Tools to build HDF5, then the h5fuse script will be in the utils when you build it. It won't be in the install. So you'll have to do that for older versions. And just a reminder, I talked about it a few Call the Doctors, and Jordan has also gave a talk about how to use the subfiling. He discussed a little bit about h5fuse script. Basically, it uses DD to copy at a certain offset the subfiles into the HDF5 file. So I'll go into how to use so you can use it HDFuse in two ways. You can either write, for example, you can loop through all your application, your simulation, and then you'll have a whole bunch of fuse files left. And then you can do, if you're using on a supercomputer, you can do another batch JS run or S run job to run this h5fuse on all those subfiles to put them all back. So that's one option, is to run it after you run your application. The other option is to call that fuse file within your application itself. So you would write your time step, and then you would call fuse to fuse that file back into an HDF5 file, and then go on to your next time step. So the way I'm going to do it, show it today, is calling the h5fuse application or script within the application itself. So if you want to look at the example, I talked about it before, that we have Cabana now, which is on GitHub, has an HDF option for outputting it. And then I haven't got it into their repo yet. It's a PR that it can do subfiling as well. So, and I have an application that's called ExaMPM that I've added subfiling to be able to do subfiling. So it calls, essentially, I left out the part, but you can go look at it here in this solver. So it essentially loops through the time steps, and at a certain frequency, it dumps HDF5 files. So it did that step before, and in this case, I outputted subfiling. I turned on subfiling and outputted subfiling. So then right after that step, I call the fuse utility. So this is what I'm showing here. And so basically I have only Ryan rank do the fusing. So it's essentially what it does is you have that one rank, the MPI rank. So in this case, in ExaMPM, they don't use the CPU at all. It's all the work is all done on the GPU. So basically I have the free reign of using the CPU to do all this fusing without, it shouldn't affect the GPU workload. And so basically you have it fork here, and then you have you give it the name of the I guess the output dump. So they do particles, and then they put the time step number and then the HDF5 file. So you'll have a whole bunch of subfiles with that prefix, and because subfiling adds to the base name to the HDF5 file information for each subfile. So first thing you have to do is determine the directory where the configuration file is, and you can get that. It's either at the current configuration, or if you have the environment variable set to put the config file somewhere else, which, for example, if you're doing node local storage, or you're writing to node local storage, you usually want to put your config file on the global file system. So in this case, which I'll show on Frontier, where I'm using node local storage, I set the config file to be on the in Lustre file system on Frontier. So once you have where the config file is for the subfiles, which tells the name of all the subfiles, then you have to let me see. Once you have to figure out the name of the config file, and for that there's a macro in HDF5, this h5fd subfiling config file name template. that gives you the name of the file. Basically, it has you have to get the file info standard INO. That's in the number, the file number. Let me see let me see which call the struct, the stat. You get the stat file name struct, and that gives you that node number. That's part of the file name. So once you have that, you have the config name, the config file name. Then you can call, once you have the location of that and the actual name of the config file, then you use the fuse utility. Here I set it up so that the args, this is the name of the fuse, and then you can have an option to remove the subfiles as you process them. So in this case, I want to remove the subfiles when they've been processed. -v is verbose, and then you give it the -f is the name of the config file. And once you have that, you give that to execute on that fork. And the second part is to check to see that fork process completed, and that's what this second part does. And so that's how you would call the h5fuse from the application itself. Is there any questions about how to do that? Does it make sense? Okay, so here's a couple examples on Frontier. So I ran on 1,024 nodes, and I have the default settings for subfiling, and it was turned out to be 900 gigabytes per file per output dump total, and I outputted 5 times. So what you see here is, and I ran it 4 times here. So this is the time it took to fuse the files back together. So roughly, so for each time step, these are all the times from all the ranks that are fusing. So it's 1 rank per node. So you have 1,024 times essentially. And so this is the min max and some outliers that you can see. And there's one that for some reason took a long time, which kind of messed up the stats, but that was probably some system issue, because the rest of them, if you look at runs 2, 3, and 4, the job got killed because this took a long time. So it didn't get the other 2, but otherwise you can see that's pretty consistent. So going from so this does a fuse from no local storage to the Lustre file system on Frontier. So average, it takes around 40 seconds to fuse a roughly 90, almost a terabyte file from the no local storage to the Lustre. Now, if you look at the time, now then I timed the actual simulation time. So here we see, this is so this is the first one here is with fuse. So you're fusing within the application. The second is without fusing it. So ideally you'd want to have them both the same, because you don't want your fuse utility affecting your normal IO. So this is with IO, but doesn't fuse the files back. It just writes the subfiles, and this is with fusing those subfiles within the program. So right now I'm kind of currently seeing why it's not overlap, why it's affecting the time it's taking to complete the application. This one makes sense because this was because that one took forever, but the other 2, if you look, it's roughly 40 seconds for 40 times 5, that's 200 seconds. And if you look at it, it's roughly 200 seconds. So it seems like it's waiting, or it's not really happening in the background. So we're still looking into that, but that's kind of the idea by using h5fuse within the application, that it should try to hide the fusing it in the background, especially if you're using GPUs only and the CPU is free. It should at least try to hide it. So I don't know. but that's
Question.
currently where we're at.
Um, how many nodes were you running this on?
1024 nodes.
So does the fuse script is able to access each of the local subfiles on each node, even though it's node local storage? Or how do you run this if your node local storage is only available on a node and you don't have any global access to the node? Does that make sense?
Well, when I run, unfortunately, I couldn't get the batch script up because Frontier was down. But when I run it, I have only run 1024 nodes. So each process that gets created has access to that node's node local storage. So when you run h5fuse, it only fuses the ones that node has access to. So it'll look at the subfiles on the node itself, on the node local storage, and just fuse those files. So it's
Okay,
handled in the script.
and then it writes. So say there were like, I don't know, however many, you then created X number of fused files, one from each of the nodes, and wrote it to Lustre. Can you then run fuse again to fuse those sub ones into a single file?
I mean, you have, well, what I'm doing, I'm fusing it into a single HCF5 file on the Lustre file system. So each node local storage has a sub file associated with each time step, right?
Right.
So I will take those sub files on that node local storage, fuse it and copy that using DD essentially into the HDF5 file on the global file system. Does that make sense?
I guess I'm getting confused by node local. To me, on some of our systems, node local means you have to be on that specific node to be able to access that file. But
Right.
then
That's
you're
correct.
running a fuse script that's running on your fuse script is only running on one node, right?
No, it's running on all the nodes, the fuse script. All the nodes will execute the fuse script, but the fuse script knows which files that have, I mean, it will read through the configuration file and know which ones that node that's on that node local storage. So it will only do those sub files that it has access to.
And then they just write into a specific offset into the global file on Lustre. And then because each node knows where its offset is into that global file, you end up with a single global consistent file.
Correct.
Okay.
Yeah. And currently for Gabbana, since they're doing everything on GPU, they copy everything to the CPU memory. And then so that's all being called. So when I do srun, I do 1024 because I'm not using the GPUs at all, right? So I'm just doing the MPI runs from on the CPU for HDF5. I mean, the other option is, like I said, you could do, if you wanted to do fuse afterwards, you could do then JS run with, so if you had 1024, you could do JS run with 1024 processes and just make sure that you have one process per node. But I mean, yeah, you'd have to have the same number of nodes that you ran the application with. But you'd have to make sure that you had one rank per node. Because you have to submit another job so that, like you said, the node only has access to the process only has access to the node local storage that it's on. So you have to have a process for each of those nodes. If that makes sense. That's why it's kind of maybe easier to do it within the application. So you don't have to do a second time. You don't have to submit a second. I mean, you can do it within the same script after you're done with your application to just do JS run again. But it'd be nice if you can do it from any application and not have to do that again. Does that make sense? Great.
Yeah, that answers it, I think. I guess when you're running it in the application, you said if I'm rank 0, run the script, but isn't it if I'm,
Yeah, I should have mentioned that. It's I do a shared memory. So I figure out which, when it's rank 0, I mean the rank 0 of that node that has the same shared memory. So I split the communicator and I split it
Okay.
according to who's sharing the same memory. So that's going to be on the node. Is I do that, and I choose the rank 0 as the minimum of that shared memory. So it only does one rank on that node. Yeah, that's a good point. Sorry, I forgot to
Okay,
mention
that
that.
makes more sense.
Mhm. So I think it's in Cabana where I actually put that. Yeah, but yeah, I split the communicator so that this PID, this underscore rank is actually the smallest rank on that node. Any other questions? Okay. I guess that's it.
I guess I have a
Oh.
general question, it's related to the subfiling, but with so if I'm running, say, netcdf to an HDF5 file or CGNS to an HDF5 file, how much change needs to be made to CGNS or netcdf to allow me to run subfiling with them? Is it something that I can control by, I guess I need, there's some environment variables or something that I could set up in my app that would short circuit around netcdf or CGNS, or do I need to modify the actual netcdf and CGNS libraries to take account of subfiling?
In CGNS, I do that in the subfiling, so I have it already there. All you have to do is where you do the MPIO driver. So you would replace that with the subfiling driver, and you can either trigger that with some kind of config for netcdf or CGNS, or some environment variable that you say you want to use subfiling. So it will use that instead.
Okay.
So you have to just change that one line. Now, I did add in CGNS that if you want to do some configurations within the application itself, and I mean, you can do everything through the environment variables that to configure it itself. But if you want to do it hard coded into the application, you can make a struct, and then you can when you call the subfiling driver, it has an option to, you can get the current parameters, then change those, and then set the subfiling file driver with those new configurations. So you can do it either way. If you don't want to do minimum, all you have to do is just change from switching from using the MPIO driver to the subfiling driver, and that's it.
Okay.
Anything else?
Right. And we do have a change next week. Garrett will be our presenter for next week. And I think he's talking about using AI and programming, or that's the plan so far. So we'll see everyone back here next Tuesday. Same time, 12:20 Central. All right. Thank you, everyone. Thanks, Scott.
All right, bye.